Okay, we're told that a culture of bacteria follows the exponential law. This is another way to indicate that same formula, A equal A naught e to the kt. So key phrases to watch for: exponential law, uninhibited growth, something referring to half-life. Those all mean this formula. Now A naught is the initial amount at time 0. Okay, now let's see what we have here. We're told the population tripled over a 10-hour period, so that would be when t is 10, to give us 900 bacteria. This is not telling me the initial amount, this is telling me the A value. So if I'm just putting in that information, I know 900 equals e to the t is 10. But what did I start with? It tripled to get to 900. So the initial must have been a third of that, or 300. With this information, I can now find my value k to complete the formula. So divide by 300. Oh, I get the 3 for tripling. E to the 10k. Now you could have cut to this automatically with the tripling if you wanted to, but remember that would mean you automatically not include the A naught, just the exponential. Taking natural logs, we get the natural log of 3 equals the natural log of e to the 10k. And the right hand side, because it's base e, the inverse properties of natural log and e, that cancels, and I get natural log of 3 equals 10k. Or k equals the natural log of 3 over 10. So my general formula is then A equals A naught is 300, e to the natural log of 3 over 10 times t. You can use that full k value with its formula if you want. My guess is you're going to want to approximate, and that's fine. Just make sure to keep every decimal place your calculator shows you. So this is 300 e to the 0.10986122289 t. Okay, now what's our question? How many bacteria will be present in 3 more hours, which is 13 hours total? So in reference to our starting population of 300, it's 13 for t. So 300 e to the 0.10986128289 times 13. I already have this number in my calculator, so I can use that second negative to get the previous answer. Multiply that by 13 in the exponent, and I end up with 1251.35 is what I get. Now again, it's the number of bacteria, so I can either write this as 1,251, or I can round and say, well, let's see. If I have a portion of a bacteria, I must have the entire bacteria, so you could do 1,252. Either of those answers is acceptable. Now let me show you something else that you could do. We still have to go through the exact same thing to find k. But we could look at it as saying, okay, 3 more hours. So when I start looking now, my population was 900. I'm still growing according to the same rate, so I still have this same value. But now I'll use 3 for my time, because I'm just looking at 3 hours from the 900 to where I'm at currently. And watch what happens here. 900 e to the, I gotta type this one in, 986122289 times 3. What do you know? Same answer. Okay, so there are 2 options for this one. You just got to make sure to watch the wording and get the reference. 3 more hours, if you use the 3, then you have to say that means I'm starting at 900 for this portion of the problem. If I go with 13, that's using the original initial population of 300.